Ma'am, start பண்ணுங்க ma'am.
Very good afternoon to you all. It gives me immense pleasure to welcome you all to the fourth week of 50 days webinar marathon on skill development. On behalf of B.C.A Department of Dwarkadas, Govardhandas, Vaishnav College, I would like to express my gratitude to our respected secretary, Shri Ashok Kumar Mundraji, our principal, Captain Dr. S. Santosh Babu sir, and our beloved advisor in head, Dr. T. Venmurugan sir, for encouraging us to conduct this 50 days webinar marathon. Now, I would like to call upon Mrs. S. Kavita ma'am to welcome our resource person with a short note of introduction. Over to you, ma'am.
Okay, thank you, Meena. It is my pleasure to introduce our resource person, Mr. P. Thirumal, Assistant Professor, PG and Research Department of Mathematics, Dwarakadas, Govardhandas, Vaishnav College. He has over 5 years of experience in the teaching field. He has completed his master degree in mathematics from University of Madras and his MPhil from University of Madras. He is currently doing his PhD in University of Madras. His area of interest is fixed point theory and functional analysis. He had qualified NET, JRF and SET in mathematics. Welcome you, sir. Now I am handing over the session to Mr. P. Thirumal, sir.
Good evening to all. Thank you, ma'am, for your introduction. And I would like to thank for the B.C.A department for giving this opportunity for me as a resource person today. Thank you, ma'am. Okay. Ma'am, my screen visible, ma'am?
Yes, sir. Yes, sir. Visible, sir.
Okay. Okay, ma'am. Okay. Today we'll discuss some basic mathematical concept to solve the aptitude test relation questions. So some questions we don't need the mathematical concept for solving the questions. Some visual reasoning questions, no need mathematics. Without mathematics, we can solve some questions. But some questions we need some basic mathematics to solve the questions. Okay, we'll discuss some basic concepts today. Okay, first one, divisibility conditions. We'll check 1 to 10 numbers, how to divide the divisibility conditions. The given number is divisible or not divisible. We are going to check for the numbers 1 to 10 or 11, 12 also we'll check. Second one, permutations. Next, some basic problems on combinations. Fourth one, for a given date, how to find the day, which day it falls on the given date. So we are going to see first this 4 basic concepts only today. Okay, first one, squaring a number. Okay, squaring of a number whose unit digit is 5. So unit digit 5 means for any given number, the unit digit is 5 means that square number we can find easily. So how to find the number? First, we'll see some examples. First, 45 square. So we need to square the number 45. We know the concept 45 multiplying by 45, we are getting the answer. But without multiplying the normal calculation, how to find the square value? Okay, first 45 multiplying the value 45. The last 2 digits always ends with 25. That is 25 is the last 2 digits. For any number, the unit digit value 5 means its square value always ends with 25. So 45 multiplying by 45, we are getting the last 2 digits, it's 25. Okay, second, multiply the tens value. So tens value means here 4. 4 with the next number 4 plus 1. That is 4 into 5 is 20. So the required answer, that is 45 square is 2025. So first 2 digits, this is 4 multiplying by 4 plus 1. This value is 20. This is the first 2 place. Remaining 2 place value, this always it's unit digit value and tens place value. It ends with 25. So the required number is 2025. Okay, we'll see some more examples. Here, suppose 55 square. We need to calculate 55 square. So the meaning is just we need to calculate 55 multiplying by the value, same number. It's just a square of a number. 55 square is 55 multiplying the value 55. So last 2 digits, it's always ends with 25. So we know first last 2 digits is 25. We need to calculate the remaining value. Here the value is 5. So 5 multiplying the next number. So 5 next number is 6. So 5 into 6, 30. So 3025. That is 3025 is the square of this number. So 55 square is 3025. Suppose 95 square. So 95 square value, the last 2 digit value is 25. So it's a unit place value 5. So its square value ends with 25. So remaining calculation, just we need to 9, this tens place value 9, the next number is 10. So 9 into 10, 90. So the required number is 9025, 9025. This is for 2-digit numbers calculation. This is work for any digit number, it will work. The same trick. Suppose 105 square, we need to calculate the square of the number 105. So again, it's a unit digit value 5. So last 2-digit value is 25. So remaining number here 10, we need to multiply 10. The next number 10, the next number is 11. So this product value is 110. So 110, 25. So 11,025 is the square of this number. So using this trick, we can find easily the square of a given number, but the unit place value is 5. 5 means we can find easily using this trick. This is work for any number. Suppose 45285. For this number also it will work, but here the unit digit value 5. We need to multiply. This number is last 2-digit number always 25. We need to find the next number 4528 multiplying with 4529. That will work for any number. But for small numbers, we can easily find without the calculation. So 55 square means the last number 25. So 5, next number is 6. 5 into 6, 30. So 3025. Without calculation, we can directly say the square of a 2-digit number. But this tricks work for large number also, but it will take the calculation. So we need to calculate here 4528 multiplying by, sorry, next number is 4529. So 4529. We need to multiply this number. This will take again a time. So for large number, it will take time, but some 2-digit number, 3-digit number, we can say easily the answer, the square of a number. Okay, just the idea is last number always, the last 2-digit always ends with 25. So remaining number, we have here 4. So next number 5. So 4 into 5 is 20. So the final answer is 2025, 2025. Okay, next. Next, divisibility rules. So first we'll see what is meant by divisible. Divisible by means when you divide one number by another number, the result is a whole number. So here whole number means it's a natural number including 0. The set of all whole numbers means 0 including natural numbers. Here natural number means 1, 2, 3, etc. These numbers are called natural numbers. So actually natural numbers, set of all natural numbers 1, 2, 3, 4, 5, etc. This is a set of all natural numbers. Here whole numbers means including 0, 0, 1, 2, 3, etc. This is a whole number, set of all whole numbers 0, 1, 2, 3, etc. This is a set of all whole numbers. Okay, when you divide one number by another number, the result is a whole number. So when dividing, we are getting the remainder is 0. Then we can say the number, given number is divisible by a given number. Okay. First examples. So 21 is divisible by 7. This is for an example. 21 is divisible by 7 means 21 divided by 7 is 3. Exactly, this is divisible. The remainder is 0. So 21 divided by 7 is 3. So this is 21 is divisible by 7. Next, 15 is not divisible by 7. Since we are dividing 15 divided by 7, we are getting the remainder value. Remainder value 1. So this is 2 multiplying by 1 by 7. It's a mixed fraction value. So here remainder is 1. So this is, we can say 15 is not divisible by 7. But we can divide 15 divided by 7. We are getting the answer is 2, 1 by 7. That is, it's a mixed fraction. But we cannot say it's 15 is divisible by 7. So a number is divisible by 7 means the remainder is 0 or the result is a whole number. The result is a whole number means we are getting the remainder value is 0. Okay. Here the reason is the result is not a whole number. So 15 is not divisible by 7. Okay, 0 is divisible by 7. Since any 0 is divisible by all the non-zero values. So 0 by 0 is not defined. So 0 is divisible by any non-zero value. Here 0 is divisible by 7 because 0 divided by 7 is 0. Here it's a whole number. 0 is a whole number. There is no remainder. So we can say 0 is divisible by 7, or simply we can say 0 is divisible by any non-zero value. Okay. Now we'll check the divisibility conditions. First one, divisible by 1. So divisible by 1 means given any integer, it's not a fraction number. So integer values. For any integer, it is always divisible by 1. First, divisible by a number 1. So given any integer means it's negative number, negative values also included. So integer, set of all integers means here 0, 1, 2, 3, etc. Here -1, -2, -3, -4, etc. So this is set of all integers. So given any integer, all the integers are divisible by 1. 0 also divisible by 1. Just now we say 0 is divisible by any non-zero value. So integers are divisible by 1. So dividing by 1 is, it's very trivial. So given any number 845 divided by 1, we can say the answer is 845. So dividing by 1 is very simple. So divisible by 1 is very simple. Next, divisible by 2. Divisible by 2. Here 2 is a even number. So for a given number is divisible by 2 means a given number is a even number. So all the even numbers are divisible by 2. So even numbers. So even numbers, how to identify the even numbers? Even numbers unit digits value 0, 2, 4, 6, 8. So this 5 values 0, 2, 4, 6, 8. This is a unit place value means the given number is a even number. So even numbers are divisible by 2. So some examples, suppose 4, 5, 8. Here unit digit value is 8. So this is divisible by 2. Here the unit digit value is 3. For this number, unit digit value 3. So this is not an even number. So this is not divisible by 2. So divisibility check by a number 2 is very simple. That is even numbers. Even numbers are divisible by 2. Even numbers means this unit digit value 0, 2, 4, 6, 8. So unit digit value, this numbers means the given number is a even number. Even numbers are divisible by 2. Okay, next, divisibility by 3. Okay, for a given number, how to check a number is divisible by 3 or not? Okay, suppose there is a number 1, 3, 2. So this is a given number. We need to check this is divisible by 3 or not. So when dividing by 3, the result is a whole number or not. That is, we are checking the remainder is 0 or not. This is the simple trick is 1, 3, 2. Just adding the unit place value, the digit value. So 1 plus 3 plus 2, sum of the digits. So 1 plus 3 plus 2, the value is 6. 6 is divisible by 3. That is, sum of the digits is divisible by 3. So the trick is sum of the digit is divisible by 3 means a given number is divisible by 3. So dividing by 3, we are checking just the sum of the digits. Sum of the digits is divisible by 3 means a given number is divisible by 3. Okay, for any large number, this will work. Suppose 91. So we are checking 91 means just check 9 plus 1. 9 plus 1 value 10. Again is a two digit number. Again we can check directly 10. 10 is divisible by 3 or not. 10 is not divisible by 3. So the result is not divisible by 3. Suppose again we can apply the same result. 9 plus 1. Here the digit value, sum of the digit value is 10. Again it's a two digit number. We can add again, this is 1 plus 0. 1 plus 0 is 1. 1 is not divisible by 3. So the original number is not divisible by 3. So 91 is not divisible by 3. Okay, suppose 384, 51. Suppose this is a number. Sum of the digits. First to calculate 3 plus 8 plus 4 plus 5 plus 1. So this value 18, 5, 10, 18, 21. So the sum value is 21. Again, we can apply the same result. 21, 2 plus 1. So 2 plus 1, 3. So sum of the digits 3. 3 is divisible by 3. So the original number is divisible by 3. So divisibility by 3 means we have to check sum of the digits is divisible by 3. So sum of the digits divisible by 3 means the given number, original number is divisible by 3. We can apply any times. Suppose we are getting the sum value is 3-digit numbers means again we can apply the same result for the sum value also. So finally we are reaching a single digit number. Single digit number means we are reaching sum value always is a positive value 1, 2, 3 up to 9. So there is no negative value possible. So we are reaching 1 to 9. 1 to 9 we can easily check that divisible by 3 means it's a multiple of 3, 6, 9. So 3, 6, 9. The sum value finally the reaching 3, 6, 9 or 0. 0 not possible here. The sum of the digit value. Only the possible values. All the digit values 0 means only the sum value 0. Otherwise we are getting non-zero value 3, 6, 9. The sum of the digits value, finally we are arriving 3, 6 or 9. Then we can say the given original number is divisible by 3. Otherwise, it is not divisible by 3. Okay, next one, divisible by 4. Divisibility by 4. So for any given number divisible by 4 means we have to check the last two digits. Last two digits divisible by 4. So for given any large number, suppose 8, 4, 6, 8, 28, 40. So this is a large number. For this number, we need to check just the last two digits. Since remaining number is a multiples of 100, that is the number is 84682800 times this times of hundreds. So this is equivalent to 846828 multiplying by 100 plus the value 40. This is equivalent to this number. So multiples of 100 always divisible by 4, since 4 times 25 is 100. So this numbers we no need to check. So remaining we need to check only the last two digits. So divisible by 4 means we need to check the last two digits only. Last two digits divisible by 4 means the original number is divisible by 4. Otherwise the original number is not divisible by 4. Okay, we'll see some examples. 842. So last two digits 42. So we need to check the 42 is divisible by 4 or not. This is not divisible by 4. Since 10 times 4 is 40, the remainder is 2. So remainder value 2. So this is not divisible. Last two digit is not divisible by 4. So the number is 842 is not divisible by 4. Suppose. Next example, 4823 4812. Okay, this is a number. So 4 crore 82 lakhs 34,812. So this is a random number. So in this number, we need to check this is divisible by 4 or not. So for the checking, just we need to check the last two digits. So 12 is divisible by 4. So 3 times 4 is 12. So last two digits divisible by 4. So the original number is divisible by 4. So if you are dividing this whole number, this is divisible by 4. So now the divisibility condition, just last two digits divisible by 4 means the original number is divisible by 4. Next, divisibility by 5. Divisible by 5. Okay. So 5. So a number is divisible by 5 means the unit digit value. The unit digit value either 0 or 5. Either 0 or 5. The number is divisible by 5 means the unit digit value either 0 or 5. Otherwise, the number is not divisible by 5. Suppose 48365. The unit digit value 5. So this is divisible by 5. 826. The unit digit value not 0 or 5. The unit digit value 6. So this is not divisible by 5. This is a random number. This is a unit digit value 0. So this is divisible by 5. So for a number means here we are using only the integer values. So for an integer, this unit digit value either 0 or 5, we can say the number is divisible by 5. Otherwise, it is not divisible by 5. Okay. Divisibility checking by 5 is very simple. The unit digit value, just by an observation, we can say the unit digit value 0. This is divisible by 5. Unit digit value is 5 divisible by 5 or 0. Otherwise, this is not divisible. This is very simple one. Divisible checking by 5. Next, divisibility by 6. Divisibility by 6. So 6. So 6 means 6 can be written as it's a 2 into 3. It's factor 2 and 3 or a factor prime factors 2 and 3. So 2 is a prime number, 3 is a prime, again a prime number. So it's prime factors 2 and 3. So divisible by 6. We are checking the divisibility condition for for 6. This is enough for checking 2 and 3. So already we know that divisible by 2 means it's a even number. So divisible by 6 means it's a even number. First we have to check it's a even number. Next condition we have to check it is divisible by 3. Divisible by 3 means it's a sum of the digits divisible by 3. Already we checked this. Divisible by 3. Sum of the digits is divisible by 3 means the original number is divisible by 3. So first it must be a even number. So divisible by 6 means it's a even number. and sum of the digits. Divisible by 3. Okay. So some examples. 841. First check this is divisible by 6 or not. First check it's a even number. This is not a even number. Unit place value 1. So it's not a even number. So this is not divisible by 2. So this is not divisible by 6 also. Second example. 811312. It's a simple number. Okay. So we have to check divisibility by 6. First check it's a even number. It's a even number. So first property satisfied. It is a even number. Next we have to check divisibility condition for 3. So 3 means it is sum of the digits divisible by 3. So first to find the sum of the digits. 8 plus 1 plus 1 plus 3 plus 1 plus 2. So the sum value 10, 13, 14, 16. So again we can apply 1 plus 6 is 7. 7 does not divide by 3. So the number is not divisible by 3. So this number 8,11,312 not divisible by 6. So divisible by 6 means it's a even number and it is divisible by 3. Divisibility checking by 3 is sum of the digits divisible by 3. Here sum of the digit is 7. So 7 is not divisible by 3. So the original number is not divisible by 6. Okay, this is a divisibility condition for 6. Next for 7. Divisible by 7. Okay, for a given integer, how to check the divisibility condition for 7? Suppose I'm I'm choosing a number 175. This is a given number, 3-digit. I'm choosing 3-digit number 175. Okay, just see the unit digit value, 5 unit place value, 5. Just double the unit place value. That is 2 times 5. 2 times 5 is 10. So unit place value 5. Just double the unit place value. The answer is 10. Just subtract this value from the remaining number. The remaining number is 17. 17 minus unit place double of the unit digit value, that is twice of the unit digit value. So 2 times 5 is 10. So 17 minus 10, the remainder is the remaining value is 7. So 17 minus this value 10 is 7. Now check this value 7. 7 is divisible by 7. It's just 1 times 7 is 7. So the original number 175 is divisible by 7. Okay, so divisibility checking by 7 is first step, just double the unit digit value. Here 5 means 2 times 5, 10. Subtract this 10 from the remaining numbers. Remaining how many numbers? Just subtract the number 17. Here 17 minus 10. This is 7. Now check the divisibility condition for this 7. So 7 is a multiple of 7. So this is 175 is divisible by 7. We'll see another example. Suppose 123. Okay, so first step, double the unit digit value, 6. So 3 into 2, 6. This is the first step. Second step, the remaining number 12. So 12 minus 6. 12 minus 6 is 6. 6 is not divisible by 7. So 123 is not divisible by 7. Okay, now we'll take another divisible number. I have some examples. 1750. Okay. 1750. This is a 4-digit number. Okay, first the unit digit value 5. So 5 means 0 times 2. Again it's 0. So just we need to subtract 175 minus 0. Again we are getting 175. Okay, we can continue the same process. Again the unit digit value is 5. So 2 times 5. 2 times 5 is 10. That is double the unit digit value. So 2 times 5 is 10. Subtract this value, the remaining term. 17 minus 10, 7. 7 is divisible by 7. So the number 1750 is divisible by 7. So divisibility condition by 7 is just double the unit digit value and subtract the remaining numbers. Continuing this process, we can check. Finally, it reaches unit digit number. That is 129. That number is 7 means it is divisible. We are getting some other number. That is except 7, we are getting some other number means the number is not divisible by 7. Okay, simply we can take 91. So 91 means unit digit value 1. Double the number is 2. That is 1 into 2 is 2. Remaining number is 9. 9 minus 2. 9 minus 2 is 7. So we are getting 7 means this is divisible by 7. Suppose we are getting some other number 1, 2, 3, 4, 5, 6, 8, 9 means the number is not divisible. We are getting here 6, so the original number 123 is not divisible by 7. We are getting the final answer 7 means the number is divisible by 7. This is a divisibility condition by 7. Next, divisibility by 8. Okay. For a given number, for divisibility by 4, we are checking only the last 2 digits. Dividing by 8 means that is divisibility by 8. We have to check the last 3 digits. Last 3 digits enough to check. Suppose there is a number, given number 8412100. So for my I'm taking easy numbers. The last digit is 100. Okay, so this is a large number. Here divisibility by 8 means we have to check the last 3 digits. So 100 is divisible by 8 or not. So 100 is not divisible by 8 means the given number is not divisible by 8. Suppose 8. Since why we are checking the last 3 digits? The reason is 1000 is divisible by 8. That is the reason. Remaining numbers are multiples of 1000. Here it is, the number is 8412. That is 8412 times 1000. So last 3 digits is enough to check the divisibility conditions. Okay, next. So by 4 means we are checking last 2 digits. Here by 8 means last 3 digits, it's enough to check. Next, by 9. Divisibility by 9 is same as divisibility by 3. Here also sum of the digits. Sum of the digits divisible by 9. Here sum of the digits is divisible by 9 means the original number is divisible by 9. So 812. So just find the sum of the digits. 8 plus 1 plus 2. The value is 11. Again 1 plus 1 is 2. This is not divisible by 9. So this number is not divisible by 9. So sum of the digits is divisible by 9 means the original number is divisible by 9. Okay, suppose 8, 1, 7, 2. I'm taking this number. So this is 8172. Find the sum of the digits. 8 plus 1 plus 7 plus 2. Here this is 9, 18. Again 1 plus 8 is 9. So sum of the digits is 9. We are getting sum of the digits is 9. This is divisible by 9. So the number 8172 is divisible by 9. By 3 we are checking sum of the digits divisible by 9. Here sum of the digits divisible by 9 means the original number is divisible by 9. Why we are checking just the reason is we are just adding the unit place value. That is sum of the digits only we are adding. Remaining always divisible. Since 10, this can be written as 9 plus 1. So 9 is divisible by 9. 100 means we can write this is 99 plus 1. So 99 is divisible by 9. 11 times 9 is 99. 1000. This can be written as 999 plus 1. So 999 is divisible by 9. So 111. So 111 times 9 is 999. So remaining, just we are checking the unit place only we are adding. This is a remainder. 10 is divisible by 9, the remainder is 1. 100 means we are getting the remainder 1. 1000 means we are getting the remainder 1. Here 2000 means we are getting the remainder 2. Since 2000 can be written as 1000 plus 1000. When dividing by 9, we are getting 1 remainder here. Here again 1 remainder. 1 plus 1 is 2. That is the place value 2. So that's why we are adding just unit place value. That is sum of the digits. So for any given large number 1, 2, 8, 7, 4, 5, 6, 7, 8. For any large number, just adding the number, sum of the digits. The sum of the digits divisible by 9 means the original number is divisible by 9. The reason is remaining. It's 7. It's 70. 70 can be written as 7 times 10. Here in 10, that is 9. So remaining is 7. Here 600 means 600 can be written as 6 times 100. Here 100, we know the result 99 plus 1. So the remaining is 6. Here 5000 means 5 times 1000. 1000 when dividing 1000 by 9, we are getting 1. 1 is the remainder. So here there are 5000s. So there are 5. So just the remainder values in this place value 1, 2, 8, 7, 4, 5, 6, 7, 8. So just we need to check the sum of the digits. Sum of the digits is divisible by 9 means the original number is divisible by 9. This is the reason for we are checking the sum of the digits. Okay. Next, divisible by 10. A given integer is divisible by 10 means the unit digit value 0. The unit digit value is 0. Otherwise, the number is not divisible by 10. So, a given number is divisible by 10 means that unit digit value 0. Otherwise, it is not divisible by 0. 8, 4, 0, 1, 2, 8, 3, 8, 4, 3, 6, 8, 0. Okay, here the unit digit value is 0. This is divisible by 10. Here the unit digit value 8. This is not divisible by 10. Here 0 divisible by 10. Here 8. This is not divisible by 10. So checking 10 is very simple. Unit digit value 0 means the given number is divisible by 10. Okay. Now we'll just recall the concept. First one, divisibility by 1. So any integer is divisible by 1. Second one, divisibility by 2. The last digit is even. Even number means the unit digit value 0, 2, 4, 6 or 8. Unit digit value, this numbers contain means the number is a even number. This is divisible by 2. Next, divisible by 3 means sum of the digits is divisible by 3. Divisible by 4, last two digits are divisible by 4. Next, divisibility by 5 means the last digits either 0 or 5. Next, divisible by 6. Divisible by 6 means it's an even number. Also, it's divisible by 3. It's a factors 2 and 3. It is divisible by 2 means it's an even number. Divisible by 3, just we need to check sum of the digits. Sum of the digits divisible by 3 means it is divisible by 3. And even number means it is also divisible by 6. Divisible by 7. Doubling the last two digits and subtract from the number made by the other digits. So just find the last digit, that is the unit digit value, double the number and subtract the remaining values. Continuing this process, finally we are arriving 7 means the original number is divisible by 7, otherwise not divisible by 7. Next, divisible by 8, last three digits. Checking last three digits are divisible by 8 means the original number is divisible by 8. The reason is for 4 we are checking last two digit, that is remaining is a multiples of 100. 100 is divisible by 4. So just we are checking the last two digits. Here divisible by 8 means 1000 is divided by 8, that is 125 into 8 is 1000. So 1000 dividing by 8. So the remaining number, the three digit numbers only enough to check the divisible condition by 8. So last three digits divisible by 8 means the original number is divisible by 8. Next, divisible by 9. Sum of the digits divisible by 9 means the original number divisible by 9. Next, divisible by 10. The number ends with 0. Okay, the unit digit value 0 means the given number is divisible by 10. So those are divisibility conditions for 0 to 10. 11 also we can check. 11 means alternate permutations. So we kept continuing this process and divisible conditions for 11 and 12, 13, 14. Now you are getting some idea. 12 means we need to check its factors are 3 into 4. Divisible by 3 and divisible by 4 means this is divisible by 12. For 13 we have to check the separate condition. For 11, 11 also simple. Suppose there is a number 1, 8, 3, 1, 2. There is some number means first check the alternate sum of this alternate numbers. 1, 3, 2. This sum value 1 plus 3, 1 plus 3 plus 2. This sum value 6. The remaining sum value 1 plus 8 is 9. Here 9, this value 6. Find the difference. 9 minus 6 is 3. This is not a multiple of 11. So this is not divisible by 11. 121. Here first number and the last number. 1 plus 1 is 2. Middle there is only one number 2. The sum value is 2. 2 minus 2 is 0. It's divisible by 11. So the number 121 is divisible by 11. So divisible condition by 11 means just alternate sum value. So, suppose 1, 3, 4, 6, 2, 3, 4. This there is a number means just we need to check 1, 4, 2, 4. This sum value minus the remaining sum value 3 plus 6 plus 3. This difference is a multiple of 11. Multiple of 11 or 0. Multiple of 11 or 0 means the original number is divisible by 11. Otherwise, this is not divisible by 11. So we can continue this process, but up to 10 is enough. Okay, next topic, permutations. Okay, permutation. Suppose three friends A, B, and C have to stand in the line for a photograph. So there are three friends A, B, C, just a naming A, B, C. The standing for a photograph. In how many order can they stand? So how many orders? A, B, C. Suppose in first place A, second place B, third place C. Otherwise, they can change the position. In the first place B, second place A, third place C. That is, the possible arrangements from left to right are A, B, C. This is one position. A, first place A, second in the second position B, third place the person C. Otherwise, A, C, B, the last two person changing the position. Or B, A, C. This is a possible position. Again, B, C, A in starting first position B, remaining C, A. Next, C, B, A. Next, C, A, B. So there are six possible ways for in a line. They are standing for a photograph. A, B, C. Three-person means there are six possible ways. So if three objects have to arranged in row, there are 3 factorial possible permutations. So how many possible arrangements? So here there are 3 factorial possible permutations. So there are three objects. So assuming 3 objects means 3 factorial. Suppose there are 4 objects means possible basis 4 factorial. Here factorial means 1, 2, 3 up to 3. This is 3 factorial. So n factorial means just 1, 2, 3, 4 up to the number n. This is n factorial. So here 3 factorial means 1, 2, 3. Its value is 6. 4 factorial means 1, 2, 3, 4. 24. This is a 4 factorial. Factorial means up to that number 1, 2, 3 up to 4. N factorial means up to the number n. This product will give the factorial of this number. So there are 3 objects means the number of possible arrangements in a row, 3 factorial ways. That is 6 possible ways. These are all the 6 possible ways. Suppose there are 4 objects means the number of permutations of 4 objects taken all at time is 4 factorial. That is 24 ways. There are 24 possible ways we can arrange the 4 objects. Suppose if n objects have to arrange in a line, there are n factorial possible arrangements for the permutation or permutation. So here number of possible arrangements in a row. So just n factorial. N number of objects means in a row we can arrange n factorial ways. The possible arrangements are n factorial. Okay, suppose n value large, n this is npr. There are n objects. We are going to choose r objects from the n objects. This is denoted by npr permutation. So this is p is denoted by permutation npr. So npr, this is defined by n factorial by n minus r factorial. I'm not going to derive these formulas. Just I'm giving directly the formula. npr permutation means in n objects, we are going to choose r objects. The number of possible arrangements are n factorial by n minus r factorial. So suppose there are 4 objects. In this 4 objects, we are going to choose 3 objects. We are arranging 3 we are going to choose 3 arrangements. So how many possible ways selecting the 3 objects? So there are 4 objects. 1, 2, 3, 4. We are going to choose 3 objects from 4. So how many possible ways can choose the 3 objects from the 4 objects? So this is 4p3. So 4 factorial, n factorial value here 4 factorial by n minus r factorial. So n minus r means here 4 minus 3 factorial. So 4 factorial divided by 4 minus 3 is 1 factorial. So 1 factorial value 1, 4 factorial value is 24. So there are 24 possible ways we can choose the 3 objects from the 4 objects. So npr means it's a permutation. npr is defined by n factorial by n minus r factorial. Okay, we'll see examples. A number of 4 different digits is formed with the use of the digits 1, 2, 3, 4, and 5 in all possible ways. Okay, so we are forming a 4-digit number using the digits 1, 2, 3, 4, and 5. So we are using 5 numbers 1, 2, 3, 4, 5. We are using 5 numbers, but we are writing a 4-digit numbers. Okay, first question: how many such numbers can be formed? So we are using 5 numbers, but we are going to form a 4 different digits. So 4-digit number. So there are 5 numbers. In this, we are using only 4 different digits. So this is equivalent to 5p4. So in five numbers, we are choosing 4 numbers. So 5p4 means 5 factorial divided by 5 minus 4 factorial. This is equivalent to 5 factorial. So 5 into 4 into 3 into 2 into 1. So this product will give 120. So there are 120 ways we can form a 4 different digit numbers. 4-digit numbers using the digits 1, 2, 3, 4 and 5. So this is equivalent to 5p4. So this is a permutation. In a 5 numbers, we are choosing a 4 numbers. Okay, next. How many these are even numbers? So already now we checked even number means its unit digit value either 0, 2, 4, 6 or 8. So even number means 0, 2, 4, 6, 8. This is the unit digit value. But here we have only 1, 2, 3, 4, 5. The possible ways, suppose the unit digit value 2 and 4. We have only 2 numbers. Either the unit digit value 2 and 4 means the given number is a even number. We are using the unit digit value 1, 3, 5 means the number is an odd number. So we are finding how many of this are even number. There are 120 possible ways. In this, how many numbers are even number? So there is a restriction. That is, for even number, last digits must be 2 or 4. So even number means there is a possible ways 0, 2, 4, 6, 8. But here we are using only the digits 1, 2, 3, 4 and 5. So here possible ways 2 and 4. So only 2 possibilities, 2 and 4, which is filled in 2 numbers. We are going to choose one number. That is a unit digit value, either 2 or 4. So there are 2 ways. That is 2p1. There are 2 number. In this, we are going to choose one number. So 2p1 ways. And remaining 3 places filled using the remaining numbers. The remaining number is 1, 3 and 5. There are 3 numbers. In this 3 numbers, remaining in this 4 digits, we are going to choose 4p3 ways. That is, we are remaining, we have 3 numbers 1, 3 and 5. So 4p3 ways, remaining 3 places filled from the remaining 4 digits is 4p3. So the required number of ways is, where the unit digit value we can fill in 2 ways. The remaining 3 digits can be filled in 24 ways. That is 4p3. The total number of possible ways is 2 times 24. That is 48 ways. So there are 48 numbers. In this, there are 48 numbers are even numbers. So using the 5 digits, we can find 4-digit number, different digits. Digits are different. 120 numbers we can form. In this 120 numbers, 48 numbers are even numbers. That is, even numbers means we can put an extra condition for the unit digits. Unit digit always here 2 or 4. So there are 2 possible ways only. So remaining numbers can be filled in 24 ways. The total possible ways is 2 times 24, 48. Okay, next. Permutation and combinations. So permutation means number of arrangement or listing of objects. So permutation means number of arrangements, but in a combinations, it's different. We'll see. If the ordering of the object is matter, here ordering is of the ordering, we can count the ordering. Next, the permutation formula is NPR, but in a combinations, number of selections or grouping of objects. Here, ordering of the objects does not matter. Here, ordering is important. Here, order is not matter. The simple example, suppose there are three persons A, B, C. First example, we see that they are standing in a row for a photograph. There are 6 possible ways. So A, B, C, or they can stand B, A, C, and C, A, B. So we can write the 6 possible arrangement for the 3%. Suppose using this 3%, we can find a group or selecting. Suppose they are forming a group using this 3 members. So 3 members means A, B, C. All the 3 members in this group. There are only one possible way forming a group using the 3 members. So A, B, C and B, A, C. This both are same group. The number of members is 3. A, B, C, 3 members in this group. In this group also there are 3 members, B, A, C. This both are same members in the group. So this is both are same group. So ordering is here not a matter. But here the order isn't important. There are possible permutations, number of possible ways. So this is a permutation. This is combinations. Okay. Here number of arrangement or listing the objects is a permutation. Here, number of selections or grouping of objects. So here there are 10 peoples. In this 10 people, we can find the number of arrangements, or choosing a 5 members means we can arrange one, suppose A, B, C, D, E, 5 members. This is different from A, B, C, E, D. Both are different objects, different arrangement in permutation. But in combination, suppose there are 5 members group. We are forming using the 10 members. We are finding a 5 members group. So A, B, C, D, E. This is one group. And A, B, C, E, D. Both the same group. It is denoted by the same group. This is both are same group. The number of members 5. Here also number of members 5. A, B, C, D, both the members again appearing in the same group. So this two groups are same group. But in permutation, this is different. So arranging is important here. So if the ordering of the object is important in permutation, but ordering of the object does not matter here. In combination, both denote the same group. So number of members same, so it is denoted by the same group. Okay, so this is denoted by NCR. The formula for NCR, NPR by R factorial. So NCR formula. Combinations. N in N object, we are going to choose R object. NCR. This is defined by NPR divided by R factorial. Just we are getting less number of arrangements for in a combination comparing with the permutation. So this is NPR dividing by R factorial. So NPR formula is N factorial by N minus R factorial. This is divided by R factorial. So finally we are getting N factorial by R factorial multiplying by N minus R factorial. So this is the formula for combination NCR. So NCR means N factorial by R factorial, N minus R factorial. So this is NCR formula. Okay, we'll see example. Okay, a mathematics club has 15 members. In that 8 are girls. 6 of the members are to be selected for a competition and half of them should be girls. Okay. So in the mathematics club, there are 15 members. In that 8 are girls. So there are 8 girls in this 15 members. Remaining 7 are boys. So in this, 6 of the members are to be selected for a competition. So 6 members we are going to choose from this 15 members. And in this selection group, half of them should be girls. So 3 persons girls, remaining 3 will be boys. Okay. How many ways of these selections are possible? So we need to check how many possible ways. There are possible selections. How many selections? Here forming a group, so we are going to use the combinations, not permutation. In permutation, the ordering is important. Here we are forming a group of 15 members. We are finding a 6 members group. So we are going to use here combinations. So NCR formula we are going to use, that is in N objects. Here N members, 15 members, we are going to select 6 members. In the 6 members, half of them should be girls. That is 6. In 6, 3 girls, 3 boys. Here there are 7 boys. Totally 15 members, 8 girls. So remaining is 7 boys. Okay. There are 8 girls and 7 boys in the mathematics club. The number of ways of selecting 6 members in that half of them girls is the possible ways. In there are 8 girls. In this 8, we are going to choose 3 girls. So in 8, we are going to choose 3. So 8C3 multiplying by boys. There are remaining half of them boys. There are 7 boys. In this 7 boys, we are going to choose 3 boys. So the combination 7C3. So 8C3 value is 56. 7 3 value is 35. So 56 into 35 is 1960. So 8C3 value combination here. 8C3 means in 8 we are going to choose 3 members. So 8C3 means NCR. This is a NPR formula. N factorial divided by R factorial, N minus R factorial. So here 8 factorial divided by 3 factorial, N minus R factorial. So N minus R means here 8 minus 3 factorial. So this is 8 factorial divided by 3 factorial. So 8 minus 3, 5 factorial. So just simplifying, we can get the answer. So this is equivalent to 8, 7, 6, 5. This is 5 factorial divided by 3 factorial, 5 factorial, 5 factorial, 5 factorial cancel. 3 factorial is 6, so 6 cancel. So remaining is 8 into 7, 56. So 8C3 value is 56. 7C3 value is 35. So 56 into 35, 1960. So there are 1960 possible ways we can select a 6 members group containing half of them girls. That is 3 girls, 3 boys. There are 1960 possible ways. So in this problem, we are going to use the combinations. Okay, so in permutation, it's an arrangement. The order is important. In a combination, grouping. That is here number of selections or grouping of objects means we are going to use a combination, that is NCR formula combination. In permutation, number of arrangements or listing the object means we are going to use the permutation. So NPR formula here NCR formula. NCR is defined by NPR divided by R factorial. Okay, that is permutation and combination. Next, find the number of squares in the given object. So how many squares are there in the square? So it contains 1, 2, 3, 4, 5. Again 1, 2, 3, 4, 5. So there are 25 squares on the square. But suppose so find how many squares in this. So finding a square means just we can count. This is one square. This is another square. This is one. This is one. So there are 4 small squares and one this large square. So there are 5 squares in this. Suppose similarly for in a so how many squares are possible squares? How many squares in this image? So here 1, 2, 3, 4, 5, 6, 7, 8, 9 plus there are single square remaining using this 1, 2, 3, 4. Again we can find the large square. So there are 9 small square and 4 2 by 2 square is 4 plus the 3 by 3. So 3 square 3 square. This is 1. So totally 14 squares. So this is equivalent to finding here in row there are 1, 2, 2 squares. In column 1, 2. So 2 rows, 2 columns. So 1 square plus 2 square. So number of square is equivalent to 1 square plus 2 square. So 1 square value 4, 2 square value is 4. So 5. So number of square is 5 here. So for this image, 1, 2, 3, 3 columns. Columns number of this is a square. So 1, 2, 3 means here also 1, 2, 3 both will be same. So here this is number of square is equivalent to 1 square plus 2 square plus 3 square. So this is equivalent to 1 plus 4 plus 9. So this is equivalent to 14. So number of square is 14. So in this image 1, 2, 3, 4, 5 in there are 5 rows and 5 columns. 1, 2, 3, 4, 5 columns and 5 rows. So now number of square is equivalent to for this image 1 square plus 2 square plus 3 square plus 4 square plus 5 square. This will give the number of square answer for this problem. So this is 1 plus 4 plus 9 plus 16 plus 25. So this is 25, 50, 54. Sorry, 55. So number of squares in this object is 55. So this is equivalent to 1 plus n number. Suppose n rows, n column means 1 square plus 2 square plus 3 square plus 4 square plus 5 square up to n square. So just finding the square. Suppose you know the formula means we can use the squaring the formula also we can use. Once again. Suppose 1 square plus 2 square plus 3 square plus 4 square up to n square we can use the formula n into n plus 1 multiplying by 2n plus 1 by 6. This is the formula. If we are substituting here n value 5 in this formula, we are getting the answer 55. So number of square is 55. Suppose they're giving some different objects. Sometimes they will give this type of images. You will see some forward messages. You can see many times. So how many squares? How to find the number of squares in this image? So first to find this numbers. So 1, 2, 3, 4. So this is equivalent. Again 1, 2, 3, 4. So number of square is 1 square plus 2 square plus 3 square plus 4 square. So this will give the answer 25 and 30. So number of square is here 30. So remaining there are in this also. This is again a 2 by 2 here. So this is 1 square plus 2 square. So there are 5 squares in this. Again in this also 1 square plus 2 square. Again there are 5 squares. So totally 30 plus 5 plus 5, 40 squares in this image. Number of squares in this image is 40. So using this trick, we can find the number of squares for these images. So 1 square, 2 square, 3 square, up to how many rows or how many columns given. This must be same. Not same means we cannot use this logic. So number of row, number of columns same means we can use the formula. Squaring sum of the first n natural number square will give the number of square in this objects. Okay. Okay, next, day calculation from a given date. So actually this is a zealous congruence. So for the Gregorian calendar, we are using the Gregorian calendar. For in this calendar, some date is given. So today is given. So today, October 5, 2021 given. So today what day we need to find? It's Sunday, Monday, Tuesday, Wednesday up to Saturday. We need to find what day. How to find? This is a formula. This formula looks like very complicated, but this is a very simple one. If you understand, no need to write this formula. Directly we can calculate. So mod 7 operation also no need. Finally, just dividing by 7 is the modulo operation 7. So h is defined by here number of weeks. Okay, I will write separately here. Okay. Okay, we'll see one simple example for this. Okay, in this 0 means Saturday. We are starting from Saturday. So 0 means Saturday, 1 means Sunday, 2 Monday, Tuesday means 3, 6 means Friday. Again 7 is 0. That is Saturday. Friday, Saturday means 0. Here Q is the day of the month. Okay, I will write here. Okay. Here Q. Here H is the final answer. We are arriving H. H is our day. We need to calculate. This will be 0 to 6. So 0 means equivalent to Saturday. So 0 means Saturday. 0 means Saturday. 1 Sunday. 2 means Monday, Tuesday, Wednesday, Thursday, and Friday. So 3, 4, 5, 6. Finally, we are going to arrive the number 0 to 6. H value will be 0 to 6. In this calculation, we are getting this. We are taking modulo 7. Modulo 7 means dividing by 7. So dividing by 7 means the remainder will be 0, 1, 2, 3, 4, 5, 6. Only the 6 possibles. We are getting the remainder 2 means the day is Monday. We are getting the remainder 5 means the day is Thursday. We are getting remainder 0. That is divisible by 7 means we are getting it's Saturday. Okay. So in this formula Q means the day of the month. So day of the month. So today is 5. So here Q value is 5. So 13 times m plus 1 divided by 5. Here m means it's a month value. So month value we are starting from March. So March, April, May, June, July, August. First, I will write all the months here. September, October, November, December. So we are starting here. 3 is equivalent to March. So March means 3. April, May, 6, 7, 8, 9, 10, 11, 12. So remaining January and February. This is Jan, February. We are not assigning 1, 2. So we are assigning here 13. January means 13, February means 14. We are assigning like this. We are not going to assign January 1, February 1. Sorry, February 2. Suppose we are using 1, 2, 3 means in this formula we are going to choose here negative sign. Finally, we are arriving at negative numbers also. There are different formulas. This is a simple formula. So suppose if you are understanding this formula, we can find easily. So just for some calculation, we are starting from 0. 0 means Saturday. It's end with 6. 6 means Friday. So March to November and December, we are assigning a number 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And January is 13, February is 14. So this is the value for month. So M value is over. Now K. K is a year of the century. So which century? Now we are going to use 20 here 20. That is dividing by 100. That is modulo 100. So we are going to use K value is 20. Next, sorry, here J value is a century. K is the year of the century. So year means year 21. So we'll see the example. I will write the formula here. So H is equivalent to Q plus, so 13 m plus 1 divided by 5. So this is floor function. Floor function, no need the mathematical meaning. Here floor function, this is floor function means nearest to integer and less than or equals to this value. So just to calculate the value and take the integer value. Just omit the fraction parts. So plus k plus k by 4 plus j by 4 plus, sorry, minus 2 times j. Finally, we take, this is a final. Finally, we are dividing by 7. That is modulo 7. Here q means, so now we'll check today. Today is 5 10 2021. So this q is a today date. So q value is 5. So here q value is 5. 13 times m plus 1. Here m means it's a month value. So m value. So 10. Here 10, it's October. October means we are assigning the value is 10. So m value is 10. The month value is 10. Next k. Here k value is year of year. So here 2021. This is a year k value. So k value is 21. Next j. Here j means which century we are finding. This is century means 2021. Just dividing by 100, we are getting this 20. So 20. Here century value 20. That's all. Just q, m, k, j value enough. Then substitute the value here. So October 5, 2021 means here q value. Q value is nothing. This is a value of q. Q value just a date. We are going to find the 5th October. So q value 5. Month, it's October. October value we are assigning 10. For each month we are assigning the value same value, but in January, February only we are assigning a different value. For a January month we are assigning 13. February months means we are using 14. So in this calculation we are going to use 13 and 14. But here October means this is 10. So m value 10. And k value the year. Here is 21. And j value in century value, just dividing by 100, we are getting 20. So 20 is a j value. Now we can substitute in this formula. So first q value 5. We are finally taking the integer value. So 13, m value 10. So 10 plus 1. So 10 plus 1 divided by 5 plus k value here 21 plus k by 4. K value 21 by 4 plus j value 20. 20 by 4 minus 2 times j value is 20. So that's all. Here this, just to memorize this formula. Here q value is date, m value month, k value the year, j value in this remaining, that's remaining value. So 2021 means here 21 10. Suppose I'm finding 8 7 19 86 means here q value 8, m value 7, k value 86, j value 19. That's all. This is k value, this is j value, this is m value, this is q value. Just using the date we can write these values. Now substitute this value in this formula. So we are getting here 5 times plus. So this is 13 multiplying by 11 divided by 5. I have an answer. This is answer is 28 point something. So I'm taking the integer value 28 plus this is 21 plus 21 by 4 is 5 point something. So integer value 5. So 20 by 4 is 5, exactly 5. So I'm taking the value 5 minus 2 times 20 is 40. So just finding this value. This is equivalent to 24. This value, just sum minus 40 value is 24. I have the answer, so I'm written directly 24. Now we'll go to this step, modulo 7. So modulo 7 means just dividing by 7. So 24 dividing by 7. The remainder is, so what is the remainder here? 3 times 7 is 21. So 22, 23, 24. 3 is the remainder. So 3 is the remainder. Here 3 is a Tuesday. So today is a Tuesday. So the answer is Tuesday. So using this formula, we can find any date. This is a zealous formula. Why it's a lengthy formula means there are some complication. No need to check anything for a given year. Suppose number of years. Suppose in this January, February, March, April, May, June. In January month we have 31 days. February 28 days or 29 days. In leap year there are 29 days. In a non-leap year 28 days. Again 31, 30, 31, 30. So July, August we have 31 days. Again 31 days. So there are complication in the February month. which year we are going to use 28, which year we are going to use 29 in a leap year. So leap year means it is divisible by 100. Sorry, divisible by 4. Leap year means just we are going to divide divisible by 4. Divisible by 4 means just we need to check the last two digits. So now 2021, just the last two digits. This is not divisible by 4. This is not a leap year. Not a leap year. So in this month, February month containing 28 days. Suppose in 2020 means February month containing 29. This is divisible by 4. So it's a leap year. So it contains 29 days in February. So there are some complicated calculation arriving while without using the formula. So in this formula, no need to check it's a leap year or non-leap year. Any year we can apply directly. Since for every 4 years, this remaining, we are choosing the interval part. The remaining will cancel here. This is terms for adjustment. For every 400 years, there is some, suppose 2100. This is for a question for you. 2100, this is divisible by 4. So 2200, 2300, 2400. So in this, suppose 2500. I'm choosing this years. So all the years are divisible by 4. But is it the question? All the years are leap year. This is divisible by 4. 2300 also divisible by 4. 2400 also divisible by 4. 2500 also divisible by 4. But not all the years are leap years. In centuries, so a year ending with 100, 200, 300, 400 means we have to check divisible by 4 as well as divisible by 400. So in which year divisible by 400? 2400 divisible by 400. So this is a leap year. 2200 not a leap year. 2300 not a leap year. 2500 also not a leap year. So in your mobile calculator, go to the date 2200. In 2200, check the February month number of days in a February. It's not a leap year. It contains only 28 days. Even it is divisible by 4. So in centuries, we have to check it is divisible by 400 or not. So 2000 is divisible by 4. Divisible by 400. So in a 2000, in February month containing 29 days. But remaining years, that is 2021, 2022, 23, etc. This years just dividing by 4. Divisible by 4 means it's a leap year. Not divided by 4 means it's not a leap year. For the centuries ending with 00, this type of years we have to check divisible by 4 as well as divisible by 400. This divisible by 400 means always divisible by 4. So divisible by 400 means it's a leap year. Otherwise, this is not a leap year. Even it is divisible by 4. Okay. For this calculation, we are adding this term. This is the adjustment term in this formula. So this year dividing by 4 and 21, this year also dividing by 4. Some adjustment. This is a formula deriving. It will take time to derive the formula. But if you know this formula, we can use it directly. Here, it's called a zealous congruence. That is finally modulo 7 means just dividing by 7. We are finding the remainder. The remainder value will give the answer. Remainder value 0 means Saturday, 1 means Sunday, 2 means Monday. So in this Q means the given date. M means month. In January month, we are going to assign 13. February month, we are going to assign 14. Remaining the same. October means 10. December means 12. Here K value, year. Here 21. Next year means 22. K by 4. We are taking the integer value. J means 20. 2021 means 20. J value 20. In 1988, we are using means J value 80. 19. K value 88. So just to substitute these values. The final answer will be 0, 1, 2, 3, 4, 5, 6. That will give the required days. 0 means Saturday, 6 means Friday. Okay. So I will stop here. Okay. Any questions?
Participants, do you have any queries? Kindly post in chat box.
I think no questions now.
Yes, sir.
Is there any questions? If you have any questions, you can ask.
No
Okay,
query.
ma'am. I
I
think
think
no,
so.
No
no
query,
questions
sir.
in comment box. Okay, ma'am.
Okay, sir. Okay. Shall we conclude the session, sir?
Okay, ma'am.
Okay. Okay. Now I would like to call upon Ms. K. Ramya to propose vote of thanks.
Thank you, ma'am. Good evening, everyone, one and all present here. It is such an honor for me to get this opportunity to thank you all. On behalf of B.C.A. Department, Dwaragadas Govardhandas Vaishnav College, I extend a warm welcome to the people in gathering. I would like to express my gratitude to all esteemed delegates of the webinar for their presence and contribution to make this webinar a great success. I extend my gratitude to our resource person, Mr. P. Thirumal, Assistant Professor, PG and Research Department of Mathematics, Dwaragadas Govardhandas Vaishnav College, Chennai, to take out time for his busy schedule for your excellent presentation with your words on this special day. A special thanks to Dr. T. Velmurugan, Advisor and Head of the Department of B.C.A., for providing immense support to make the webinar successful. I must thank the organizing team for working hard for the past few days to make the webinar successful. I thank all the participation for active participation. Once again, I thank everyone.
Thank you, Ramya. Okay. Let's wind up the session.
Yes, ma'am.
Yes.
En kutrava, ma'am.
கொடுத்துருங்க